Okay, 7.2 is about the properties of parallelograms. So the very first thing that we need to do is talk about what a parallelogram is. Okay, so a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay, so theorem 7.3, parallelogram opposite sides theorem, says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay, so you can see here, these two hash marks are the same, and this one is the same as this one. Okay, so PQ, segment PQ is congruent to segment RS, and segment QR is congruent to segment PS. Okay, up above here, if you want to go back, actually, I forgot to write this one down. So PQ is parallel, is how we write that, to segment SR, and segment QR is parallel to segment PS. Okay, so now we're going to come down here to 7.4. Theorem 7.4, the parallelogram opposite angles theorem, says that if a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, so you can see here that angle Q is congruent to angle S, and angle R is congruent to angle P. Okay, so come down here to example 1. You can say, it says find the values of X and Y. So if I see here, I know that the opposite sides of a parallelogram are congruent and the opposite angles are congruent. Okay, so to solve for X, I'm going to do X plus 4 is equal to 12. Okay, so then we would subtract 4 over. X is equal to 8. Okay, and then here, Y is opposite to 65, so then Y is just equal to 65. Okay, theorem 7.5 is the parallelogram's consecutive angles theorem. So think of consecutive, well, if I was absent from school 2 consecutive days, that would mean 2 days right in a row, okay? So we want 2 angles that are right next to each other, okay, compared to what they were before, which was opposite. So now they're going to be right next to each other, and if that's the case, so if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, okay? So then I can come over here to the picture. Any combination of X plus Y here would add up to be 180 degrees, okay? So you can do X and Y here, you can do X and Y here, or so on around, okay? Now the last one on this page, 7.6, parallelogram diagonals theorem. So it says if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, so if that's the case, then we are going to say that QM, segment QM is congruent to segment MS, okay, and segment PM is congruent to segment MR. Remember that bisect means to cut in half, okay? All right, so we can turn the page there. Okay, example 2, it says, as shown, part of the extending arm of a desk lamp is a parallelogram. The angles of the parallelogram change as the lamp is raised and lowered. Find the measure of angle BCD when the measure of angle ADC is 110, okay? So I have a parallelogram here, okay, and you can kind of see it's mapped out. Okay, if this angle here is 110, so we want, what is that? ADC, so A, D to C. So this angle right here in this corner is 110 degrees, and we want to find BCD, which is over here in this corner. Okay, they're not opposite angles, so I know that then they would be consecutive angles. So I know that they add up to be 180. So I can do 180 minus 110 to figure out that the measure of angle BCD is equal to 70 degrees. Okay. Example 4 says find the coordinates of the intersection of the diagonals of quadrilateral L, M, and O with vertices of L at 1, 4. So 1, 4 is L. M is at 7, 4. N is at 6, 0. And O is at 0, 0. Okay, so it wants us to find the intersection of the diagonals. So, well, something I can write down here is that we know, well, what do we know about the diagonals? So we know that the diagonals bisect each other. So intersection would be at the midpoint of the diagonals. Okay, so you can pick either set of diagonals. It doesn't matter which 2 points. Okay, I'm going to find the diagonal between M and O. Okay, so I'm using point M and O. I'm going to do the midpoint formula. Okay, so M and O, I would do 7 plus 0 divided by 2 and 4 plus 0 divided by 2. So that would be at 3.5, or you could leave it as 7 over 2. That's fine too. 4 divided by 2 is 2. Okay. You could also have 7 over 2. Okay, so now in example 5, it says using parallelograms in the coordinate plane, three vertices of quadrilateral W, X, Y, Z are W at -1, -3. X is at -3, -2. Z is at 4, -4. Oops, I graphed something wrong. What did I graph? Oh, here, I graphed X wrong. X is at -3, +2. Gotta be careful. Okay, and this one was Z then down here. Okay, now that looks right. Okay, and I have to try to figure out where the 4th coordinate is, okay? So what we're gonna do is first we're going to graph those points, which we've already done. Okay, then we are going to find the slope of WX. Okay, we're gonna find the slope of WX. So W and X are right here. So the slope formula, remember, is the change in Y over the change in X. Okay, we have to start and end with the same points. So if I start with W, say, I would do -3 minus -3 becomes +3. Nope. Be careful. Don't do what I just did. Sorry. Okay, we would do the Y's. I'm sorry. -3 minus 2 over. Okay, started with this Y, so I have to start with this X, -1 minus -3. So now that becomes a +3. Okay, and you would get -5 over 2. Okay, so then step 3, you're going to start at Z, which is at 4, -4, and use rise over run to find Y. Okay, so then I would come over here. I'm going to start at Z. Okay, if I am going to move, I know that I'm going to move up 5, so then that means that I'm going to move left 2, okay? So up 5. So 1, 2, 3, 4, 5, and left to incorporate that -2. Okay, so that would leave me at 2, 1. Okay, and then the last thing that you need to do is just prove that they are parallel. Okay, so first we're going to find the slope of x to y. Okay, so that would be 1 minus 2 over 2 minus -3 would be +3. So that would be -1 over 5. Okay, and then we need to find the slope xy of wz, which would be -4 plus 3 because it's minus -3. And then 4 minus -1 becomes +1. So that would be, again, -1 over 5. So they are the same, so they are parallel. So y is indeed at 2, 1. Okay. And that is it for this lesson.